All right, so it's time to start revealing the secret formula for flipping. You got to understand that pinball flippers are like sacrilege to some people, so we have to get this right. They can't be too flimsy. They got to really go up fast and kind of stick to that. So there's a lot that we're going to do here, and we're just going to try our best to come as close as possible. And I think I have. You might think it's as easy as just rotating to this upper rotation and going back down again. It is actually nothing like that what we end up with. Although originally that's exactly what I tried to do, is just rotate up and down, and no. All right, so our first function here is just going to be to flip, and when we do that, let's just write in here, print flip, and obviously that refers to flipping up. And then to be a little bit more clear, we're going to put another function in here called lower, and again, we're just going to print out that it's been lowered there. What we're going to do is we're going to keep testing with the iPhone for a little while here, because this gives us the easiest environment to basically detect that we're pressing down on the screen and then releasing upward. So go ahead and head over to your touches statement or touches Swift file, and if you want, you can just take this entire statement right here and then just paste it back out again. Instead of began, though, put in here ended. Everything else is going to stay the same, except we're obviously I'm going to replace this with something else over here as well. But we can leave in this if statement, see if we're touching either the left or the right side of the screen. And I'm just going to get rid of these print statements. We don't need to see those anymore. Okay, so let's change this to how about let go left and let go right. Once you've done that, of course, you're going to get a little complaint over here that those functions don't exist. And at least for the time being, I guess we'll keep writing these functions over here, even though we could probably move them to the... Well, they're sort of shared, at least for right now, between the TV environment and the iOS environment. So we'll say let go left and let go right. And let's start moving these print statements into the actual class itself. It gives us, I think, a little bit better of a indication that everything's moving toward that. So from this point, what we're going to do is, and we can copy a little code that we already have. We can iterate through all of our children to raise or lower the left or right ones. Okay. So go ahead and paste in what you've already got. So for node in self.children, so we're going to look at all the children, and keep in mind that this will work with multiple flippers, okay? And tapped left, so that means we care about the left flippers only. So the first thing we're going to do before we start trying to cast every node in here is something that maybe it's not, is just say if node.name equals flipper left, okay? And that way it'll skip over anything that doesn't have that same name, because at least we are kind of hard coding in with our class that you're either going to have one of two names, flipper right or flipper left, okay? And then we'll make sure again that we have to do this to call a particular function inside of that flipper class, and of course that's going to be to flip. All right. We're going to do the exact same thing over here for our tapped right. And of course, let's put over here right. And while we're pasting things in, let's just go ahead and let go left. Of course, this is going to be to lower. And you can go ahead and copy all that. Flipper right. And even though we won't visually see anything, this is a good point to test. First off, just to make sure that the build actually succeeds. And then once this loads up, we can press down. You can see it says flip over here. Of course, I moved off of it, so it lowered it. But flip, lower, flip, holding down, let go, lower, and that's a great sign. All right, so once you've done that, come back over here into your flipper class. Let's go down to the flip function. And we're going to put this inside of an if statement and I'm going to go ahead and introduce a variable here called already up. All right, which means that the flipper is already up. Okay, we don't want to do this if the flipper is already in its held up position. Okay, and I think we can go ahead and get rid of that. Of course, we need to go ahead and declare this variable over here at the top of the file. So var is going to be a Boolean variable, and initially that's just going to equal false, which it would default to anyway. So as soon as basically we decide to make the flipper go up, we're going to say that already up equals true. That means that you can't kind of initiate this multiple times, which we wouldn't want, because we're going to apply a very powerful physics impulse to this, so we don't need to kind of double tap it, right? Before we do that, though, let's write self.physicsbody.dynamic is going to equal true. Now you might remember that we already set this to be true in the scene file itself, but that's something that we are going to toggle from true to false based on where the flipper's at. Okay, so obviously when we want this thing to get moving again, we're going to set this to dynamic, and we're also going to set its allows rotation to being true. Dynamic basically includes this in all of the physics simulations. You get a much more better description, nice. You get a better description over here, so just read that on your own time. And once you've done that, then we can go over here, right? Self.physicsbody.apply impulse, and wants a CG vector put in here, which sounds a lot fancier than it is. It's just basically the force that you're going to move this upwards, and we're not going to include in here any x force to this. We're just going to bump it up on the y-axis. Now keep in mind this is pinned, so just putting any force upward is just going to send it up in the the correct direction it's going to go. And this is again quite powerful, but it's enough to get the ball moving. Of course, we don't have a ball in there yet, but let's take a look at what happens. Okay, boom, right, and bam. So some obvious things we need to take care of is that we only want it to go up to its upper rotation. So we're going to have to stop it when it gets over here. Now stopping this thing with such force is very difficult, okay? But if we didn't apply an impulse over here, let's say we just try to rotate this to its upper rotation, that doesn't end up moving the ball, okay? Not as you would expect, right? And obviously I can't hit this more than once because already up has been set to true. So we have to use the physics that we've got in here to move that ball around. So let's go ahead and work on the lower function for right now, even though we're kind of missing a little bit of an in-between step here where we actually lock it up. But at least once we have this in here, we can kind of tinker around with making the flipper go up more than once. And a lot of the reason for that is because we're now setting our already up variable back to false again. And even though so far we haven't actually set the dynamic and allows rotation to false, let's go ahead and put in here that they are going to be true, because we're going to lower this again. And again, in this one little in-between step, we will set them to false when the flippers go up, so it makes sense to set them back to true here. And then what we're gonna do is remove any sort of velocity. So we're gonna go over here and just write physics body dot velocity. This is gonna equal CG vector make. So set that back down to 0 and 0. It should have a velocity based on this impulse getting applied to it. And just as kind of to be honest, I didn't test this too much to see if it made any real difference, but let's go ahead and put it in there anyway. Just put the angular velocity back down to 0 as well. And all right, now here's the important part. What we're going to do is write flip. There's going to be an SK action, and this is one of the times where we actually do use the rotate to angle option. So this is and actually we want this to be a rotate to angle, so get rid of that. And then here, Just gotta start it over again. So inside of here, we're going to put degrees to radians, and regardless of which flipper it is, we're going to move it back down to its lower rotation. And pinball flippers typically go back down pretty quick, so I'm going to actually put a duration of just 0.1 here. It's obviously something that you could adjust yourself if you wanted, and here we go. We got a little bit too much in that statement. So from there, what we're going to do is put in another SK action. So it's going to be SK action equals SK action.run block. And this is our first time running into these in this lesson. It's a great way to call any other line of code that you want as part of your action sequence. So inside of this opening and closing squiggly bracket, we can reference any other function. You do need to put in here self. And this is going to be a function that we've yet to actually write, which is going to be lock flipper down. So put that right there. And then we're going to write self.runAction, and we could have set this up in a separate line, but we don't really need to here. This is a slightly more concise way of doing it. We're just going to write skaction.sequence, and then inside of these two straight brackets, we just list out the SK actions that we want to run in order. So we've got flip, run, and I'm going to basically label this action with a key, just a key name. So I'm going to call this lower than lock, okay? And that's not THAN, we're lowering it, then we're going to lock the flipper back down in that lower rotation. And when we lock it, we are going to set its dynamic and allows rotation properties to being false. But we first need to write this little function right here. So let's come right on down, function, and this is going to be lock flipper down, and I think it's actually a good idea, even though it should be at that lower rotation. Let's just go ahead and set it at the lower rotation anyway, equaling CG float. Oh, here we go. Oh, actually, sorry, I don't need to put in there CG float. And one of the reasons for this is we could call this function elsewhere, outside of this statement, where maybe we, by default we want to set the flippers down. So we would, call this, set them at their lower rotation, and then lock them up. So from here, we're actually going to call a more general function just called lock flipper, and we'll write that outside of here. And the reason I'm separating it from this function is that we're going to call this in a couple places, in particular when we lock the flippers in their upper rotation as well. So we're just, kind of combining resources, so to speak. All right, so inside of here, what we're going to do, and we can copy some of our code. Let's just take all this. We're going to say lock flipper. All right, so dynamic is going to be set to false. That means that if a ball bumps up against it when it's in this locked position, the ball can't nudge the flipper around. And we're also going to shut off the rotation right here. I think it's just a good idea to make doubly sure that we've set the velocity back down to 0 and 0. Same for the angular velocity. And, you could even, as I was saying before, I haven't fully tested this without all of these, actions in here, but why not? Let's set the apply impulse at 0, 0. There's just all these kind of ways that we could think to just totally lock this thing up. And maybe it would probably be best to do all those after that. The one I really kind of doubt would make any difference at this point is that apply impulse. But I think what we've got is going to lock our flipper. Let's, before we even test this, let's go ahead and put in here a lock flipper up function, and it's just going to look exactly like this with the upper rotation in there, and then we just skip on down to locking up the flipper. All right, so once you've done that, we should be able to build it again. And even though the flipper won't actually get locked up at its upper rotation yet, it will get reset back down when we let go to the lower rotation. All right, so you can kind of just press down, and it's going to go back down to where it was before. So, this is obviously not how pinball works, but this could be what you'd want to see in whatever physics game that you're making that is not necessarily pinball. It's kind of a fun little thing to do. I mean, when I was testing this, I just found myself kind of hitting this over and over again like I am now. So just keep in mind that, you know, the difference between pinball and a game where maybe a ball comes down and you want to hit it into a hole or off screen or you know, basically the equivalent of the ball going down here, but up here would be, that could be like a soccer game or something like that, you know. Ball comes down, you get one chance to hit it, try to get it past the goalkeeper, something like that, you know. And so maybe this version makes more sense for that. I don't know. All right. So what we've got to do next is a little bit more complicated than you think. We are going to start working in our game scene class with the SK Physics Contact Delegate, because what we're actually going to do, and let me bring it up, in the scene file, is put an invisible barrier here that only the flippers are going to be able to contact, and then that's what's actually going to trigger that it's time for them to stop. And I found that to be the most reliable way to really get these guys stopping at exactly when they should. And even then, there's a little bit of a possible wobble after that. Occasionally see it, sometimes you don't. But it's a little bit of work, and I think we should start a new video just for this, and it'll also give you a starting point for, you know, dealing with your SK Physics contacts in the main scene.